Introduction to Organic Chemistry. Now, it does say introduction, where there's a lot of definitions, key details you do need to know. And I haven't gone through Introduction to Organic Chemistry in a while, a long time. And so I was like, this is time to go through it. And it's a pretty short topic as well. So definition of general formula, an algebraic formula that can describe any member of a family of compounds. Definition of empirical formula, the simplest ratio of atoms of each element in a compound. Molecular formula, the actual number of atoms of each element in a molecule. Structural formula shows the atoms carbon by carbon with attached hydrogen functional groups. Skeletal formula shows the bonds of the carbon skeleton only with any functional groups. Displayed formula shows how all the atoms are arranged and all the bonds between them. Homologous series is a group of compounds that contain the same functional group and they will all be represented by the same general formula. Group of compounds that contain the same functional group all represented by the same general formula. Functional group reactive part molecule gives it most of its chemical properties. Nomenclature, naming of organic compounds. Naming organic compounds. So we count carbons in a long continuous chain containing a functional group. The main functional group of the molecule gives you the suffix, the end of the name. The number of carbons in longest chain, so that carbon main functional group attached has the lowest possible number. That's really important. Because let's say you have a molecule, pentan 2-ol, right? You've got methane, ethane, propane, butane, pentane, and the OH groups on the second carbon. If you count from there, but if you count from the other way, from the left-hand side, it'd be 1, 2, 3, it would definitely wouldn't be pentan 2-ol, and that's the really important thing. You need to number it so that the carbon with the main functional group attached has the lowest number. That's what you want. If you have more than one longest chain, pick the one with the most side chains. Right carbon number functional group is on before the suffix. Any side chains are added as prefixes at the start of the name. Alphabetical order with the number of carbons each attached to. State 2 key advantages of IUPAC rules. Scientific ideas can be communicated across the globe effectively, easier for scientists to test each other's work and confirm or dispute new theories. Scientific ideas can be communicated across the globe effectively, easier for scientists to test each other's work and confirm or dispute new theories. Isomers, molecules with the same molecular formula but atoms are arranged differently. Molecules with the same molecular formula but atoms are arranged differently. State 2 types of isomers: structural isomers or stereoisomers. Structural isomers are the same molecular formula but different structural formula. 3 types of structural formula: chain isomers, functional group isomers, position isomers. Chain isomers, different arrangement of carbon skeletons, straight chain or branch chain. Functional group isomers have the same atoms arranged in different functional groups. Position isomers have the same skeleton / same groups of atoms attached, but different groups of atoms attached to different carbon atoms. Stereoisomers have the same structural formula, but a different arrangement in space. State 2 key facts about carbon-carbon double bonds. Carbon atoms with carbon-carbon double bond and atoms bonded to the carbon lie in the same plane, the planar. Atoms can't rotate around carbon-carbon double bonds like they can around single bonds, because carbon-carbon double bonds are rigid. Restricted rotation around carbon-carbon double bonds leads to a type of stereoisomerism to be formed, causing EZ stereoisomerism. Stereoisomers, both of the double bond carbons have different groups attached to them. Arrangement of groups around the double bond becomes vital. Z isomer has the same groups either above or below the double bond. Now, the reason I included this is, yes, you could say Z isomers on the same side, like to remember it. So if you've got C1C and you've got, I don't know, Cl and H and Br, 2 groups, or Cl, you get the point, right? So if the same groups above or below the double bond, well, if in the exam it says state the meaning of the term Z isomer, it might not, probably, but if it does, you can't just say obviously they're on the same side. You have to say has same groups either both above or below the double bond. E isomer has same groups positioned across the double bond. You can see the terms same groups either above or below the double bond, or both below the double bond. E isomer has the same group positioned across the double bond. Using CIP priority rules, K in gold pre-log priority rules to identify an EZ isomer. Assign a priority to 2 atoms attached to each carbon double bond. atom with a higher atomic number on each carbon is given the higher priority. If the atom is directly bonded to the carbon are the same, you need to look at the next atom in the group to work out which has higher priority. And this is an example, right? So, and this is such a I would definitely fall for this if I didn't review this topic, but no, I definitely wouldn't. But look at this. If I said to you, which one is this E isomer, same groups positioned across the double bond, Z isomer has same groups either both above or below the double bond, which one would you say? A lot of students will probably say Z because of CH3s, but if you look at which one has a higher atomic number, in this case, it is a H3C. Which one has a higher atomic number? It's chlorine. So it's actually E isomer. It's going to be E-chloro-butene, and that's really important to identify that and understand the higher atomic number. Atom with a higher atomic number on each carbon is given the higher priority.